yn prime, that's equals to n minus 1 over a naught x y2, and this is last term is our second last term is this yn and plus your non-homogeneous term, that is bx over this is bx, okay, and where this s belongs to that interval r. Okay, so okay, so here what is your matrix y? Y is a column vector which components are y1, y2 to yn, and what is your bx, and that column matrix bm is just 0, 0, and last one is bx over that is a naught x. Okay, and what is your matrix A? A here you can write here the capital Bx in the form. Okay, so here don't confuse with this Bx and Bx. Okay, so Ax equals to this matrix is important, is 0, and this place is 1, and 0, 0, 0 is 0, 0, 1, 0, 0, and similarly the last term is okay. So last line is this is first one is minus a over a0. Second line is minus a n minus over a0, and last term is minus a1 over a0. Okay, so this is your matrix. This is your matrix. Okay, and here the elements are like this. Okay, so this is your form, and this is equivalent to your main equation, that is of nth order differential equation. Okay, so if we take a simple example, and try to find this relation in that problem. Okay, so okay, so now problem is, if we take a linear equation, suppose if we take a linear equation we consider linear equation. Okay, and if this linear equation is defined like third order linear differential equation, so this is a y double prime plus 11y prime minus 6y, that equals to 0. Okay, so you have to reduce this problem in matrix form, and this is the, we take here third order linear differential equation, and of course this is a homogeneous. Here bx term is absent. Okay, so you can take any value or this equals to 0. Okay, so here what is your value of a naught here? So what is the a0? If we compare this with our standard form, so here we get what is a0. So a0 is basically this is 1. Okay, what is a1? A1 is the coefficient of that second term. This is minus 6. What is a2? A2 is 11, and what is a3 is minus 6. Okay, so if we compare this, this is a0, this is a1, a2, a3. Okay, and here we also denote this term, what is our, we take what is our y1. Y1 is the first variable, which is take this y. Okay, so see, we take y1 or y equals to y1. Okay, so we take here y equals to y1. Okay, and then we, if we differentiate this term, so this equals y prime. If we're differentiating with x, this equals to 1 prime if we're differentiating both sides. And if we denote this term as another variable y2. Okay, and similarly, if we again differentiate this term, and so this is y double prime, and that equals to y2 prime if we differentiate again. And if we call this term as y3. Okay, so now what is if we differentiate again, this term, so this becomes y triple prime. Okay, this equals to y3 prime. Okay, so here we get what is a y3 prime. Y3 prime is this thing, and what is y3? Y2 is y1 prime, and y1 is y. Okay, so now if this equation is basically equivalent to, this is equivalent to, if we write uh, this equation of system, this is equivalent to y prime that equals to ax of y. Okay, because here bx term is 0. Okay, because no bx term. Okay, so here what is y? Y is your y1, y2, and y3. And if you write this in matrix form, so what is your ax? So ax, by the formula, you can write here first term is 0. Okay, this is 1 and then 0, this first line. Then second 0, 0, and then 1. Third line is this is minus an. What is, so an is minus of, what is a3 is minus 6 over a0 is 1. Second term is this term minus 11 over 1, and third term is minus of minus 6 over 1. Okay, so this is your matrix A. This is your matrix A. Okay, so if we take
हेलो सर।
हाँ
सर ये जो आपने ऊपर मैट्रिक्स बनाई हुई है AX, थोड़ा इसको एक्सप्लेन कर दीजिए। मैं थोड़ा लेट ज्वाइन हुआ था, तो मुझे ये जो वर्क 0 0 फर्स्ट कॉलम 0 और लास्ट में माइनस a बाई an बाई a नॉट करके जो ये मैट्रिक्स आपने ऊपर बनाई।
बिल्कुल बिल्कुल, ये बहुत ही सिंपल है। आप क्या करो कि आपके पास जो स्टैंडर्ड फॉर्म थी, स्टैंडर्ड फॉर्म हमने कल एक मैट्रिक्स लिखा था जिसमें आपके पास थी इक्वेशंस थी लाइक y1 prime something function of a11 y1, okay, and so on. y2 prime equals to a21 y1, okay, and y3 prime up to yn prime. Okay, इस फॉर्म की आपकी मैट्रिक्स थी, एंड व्हाट इज मैट्रिक्स A इज द कोएफिशिएंट ऑफ दैट, एंड y प्राइम इज दिस थिंग। ये कुछ आप देखें लास्ट क्लास में कल हमने ऐसा कुछ कराया था, याद आ रही है कुछ चीजें वो? अगर आप देखें तो y प्राइम इक्वल्स टू इस फॉर्म में y2 प्राइम y3 प्राइम एंड yn प्राइम। तो इस केस में क्या है, इन दिस केस ओनली दिस टर्म इज yn प्राइम इज गिवन। ओके, so this means all if we compare this with our standard form, if we multiply this thing, so you get only if we multiply by this with y term, y means here y1 y2 up to yn. Okay, तो आप जब मल्टीप्लाई करोगे तो आपके पास बेसिकली यहाँ पे रिलेशंस क्या थे? एक तो ये इक्वेशंस थी, बट ये इक्वेशंस आई कहाँ से? ये इक्वेशंस आई थी जब आपने कुछ एज्यूम किया था, एंड दैट टर्म y1 equals to y आपने एज्यूम किया था, y1 prime equals to y2, and y2 prime equals to y3, and so on. And this equals to last one is yn minus 1 prime that equals to yn yn. ओके, तो इस ये कंडीशंस और ये जो nth ऑर्डर लीनियर डिफरेंशियल इक्वेशंस थी उसमें आप रिड्यूस हो जाएंगी प्रॉब्लम. ओके, सो दिस मींस दिस मैट्रिक्स नोटेशन इज इक्विवेलेंट टू दैट ओरिजिनल वन. ओके, तो दिस मींस आप अगर सॉल्व करो, if you write y prime means y1 prime, y2 prime up to yn prime left hand side, that equals to this matrix ax into y means y1 y2 up to yn plus bx term is this thing. Okay, so adding simply this term. Okay, and now simple matrix multiplication. So you get this first one is y1 equals to y1 2 prime equals to this thing, and this relation due to this component 1 1 1 1 1. Okay, due to this component you got this assumption, and the last yn prime by this, if you multiply by this y1 y2 here, y1 y2 with the column vector, this last term is obtained by this term plus here of course this px term, and all this term is zero. So okay, तो अगर हम इसी में हम आपको ये n क्रॉस n में थोड़ी सी मुश्किल होगी समझना, अगर बहुत ही सिंपल है वैसे, समझने कोई प्रॉब्लम नहीं, लेकिन हम यही चीज हम इस प्रॉब्लम में हम करके देखते हैं तो आपको ज्यादा क्लियर होगा. ओके, हम यही चीज सेम चीज हम इसी प्रॉब्लम करके दिखाते हैं आपकी कि कैसे ये चीज इक्विवेलेंट है इसके. ओके
ओके सर,
ठीक है, तो हम ये सेम चीज हम इसमें करते हैं. ओके, चलिए, तो नेक्स्ट पेज हम यही मैट्रिक्स लिखते हैं और यही चीज हम लिख करके हम आपको दिखाते हैं कि कैसे हम आप पर्टिकुलर केस देख लो कि कैसे ये इक्विवेलेंट है इस फॉर्म के. तो अगर ये इसके इक्विवेलेंट है तो फिर ये आपका एन फॉर्म उसी तरह से आप कर लोगे तो आपको वो भी क्लियर होगा. चलिए, तो इसको हम डिटेल हम इसको करते हैं. चलिए, ओके, सो नाउ इन नेक्स्ट पेज, यहाँ जगह नहीं है, नेक्स्ट पेज पे हम करते हैं. ओके, सो इन नेक्स्ट पेज our problem is basically our equation is okay, this is y triple prime minus 7y prime minus 6y equals to 0, and you have to show that this is equivalent to that matrix form. Okay, and what is your matrix form is y prime that equals to ax of y. Okay, because bx term is absent. And what is y here? So y is column vector y1 y2 y3. Okay, this column vector. And what is ax? Ax by that formula you got this is 0, this is 1 0 0 0 1, and in last term by calculating that term, that equals to this thing. Okay, so you got this thing. Is it clear to all of you? Okay, so here if we take what is the assumption here? Here we take that assumption is you take here y is y1, and if you differentiate this term, that is this y1 prime, if you do know this is variable y2, and if we again differentiate this equals to y2 prime, that if you do know this is y3, and we again differentiate this is y3 prime. Okay, so this is your relation. Okay, so now look here, this is y prime means y1 y2 and y3. This is y prime that equals to okay, that equals to our matrix ax, and what is ax is 0 1 0 0 0 1, which is 6 minus 11 and 6. Okay, so this is of 3 variables, so 3 cross 3 matrix. Okay, into y is y1 y2 y3, and plus bx, but bx is absent here. Okay, so no term is there. Okay, so now if we multiply this term to this equals to y1 prime y2 prime y3 prime, this is your left hand side, and if you multiply here, this is 0 and this is simply y2, so you got here y2. In this second with this 0 0, this is y3, and last one is 6 y1 minus 11 y2 plus 6 y3. Okay, so if you multiply this matrix with this, you get this thing, and this is equivalent to y1 prime is y2. Okay, y2 prime is y3, and what is y3 prime is equals to 6 y1 11 y2 6 y3. Okay, and look here, what is y3 prime? Y3 prime is y triple. So here we put here y triple derivative of that, that equals to 6. What is y1? Y1 is simply y. It is 6 of y minus 11. What is y2? So y2 is y1 prime and y2 is y1 prime. Look here, y2 is y1 prime. This condition holds. And what is y3? Y3 is y2 prime. Okay, so your assumption, that assumption you take, that comes from that matrix. That's why in this diagonal we put here 1 1 1 1 and so on. Okay, so here if we put y2, what is y2 is y1 y dash. So here we put y dash plus 6. What is y3? Y3 is y double prime. This is y double prime. Okay, so now if we rearrange this term, so you get here y triple prime minus, uh, this is minus of 6, this term is here, plus 11 y prime minus 6y, that equals to 0. Okay, so this is the same equation when we started here. Okay, तो आप अगर आप ये सब्स्टिट्यूशन लेते हो तो आपकी जो इक्वेशन है, दैट इज y प्राइम इक्वल्स टू x इक्वल्स टू y, उस केस में y आपके ये y1 y2 y3 ये वेरिएबल्स हो जाएंगे और ax जो है वो मैट्रिक्स होगी, एंड दैट मैट्रिक्स कैन बी रिटन बाय दैट फार्मूला, दैट इज 0 1 0 0 0 0 0 1 0 0 0, and last one is by using that formula, and that formula is if there are n number of variables, then a n over a0 minus a n minus 1 over a0 and up to dot dot. First term is minus a1 over a0. Okay, so here you can easily you can return this form, this third order linear differential equation in matrix notation like this. Okay, so here, so you have to find the solution of that matrix. So here we can try to find the solution. So for that, here, what is your ax is this thing. So we have to calculate what is the a minus lambda I, that equals to 0. So this implies we have to find the eigenvalues. And here, if you look here, so this becomes if you try to find the eigenvalues of that matrix. So here, I think this eigenvalues of that matrix is simply 1, 2, and 3. Okay, so here from this you can find what is the eigenvalues of this matrix. So the general required solution, rather than required solution of the given equation that is your y1. So y1 that equals to, and of course y1 is your y, so this is yx. So this equals to c1 e to the power lambda 1, this is x, c2 e to the power 2x, and c3 e to the power 3x, where c1, c2, and c3 are constant. Okay, so here you can solve easily by a matrix method this higher order linear differential equation by using simply written in matrix form, and then you have calculated what is the eigenvalues, and then try to solve the solution of that uh, problem. Okay, so the next topic is yesterday we had already discussed about how to find the particular integral. Okay, so now we solve and calculate how to find the particular integral of any differential equation. Okay, so next page, if we consider the equation that is y double prime 2 over x y prime plus 2 over x square y, and suppose this is some dx term is here. Okay, and here x is not equals to 0, because if x equals to 0, then this is a singular point. So here we denote this x doesn't belong to 0. So if we take any interval like this, okay, when x is not equals to 0, so no problem here. And here if we write this is as a linear operator, so we can write this is ly that equals to dx. Okay, so here what is a0? A0 is 1. What is a1 first term? That is minus 2 over x. What is a2? This is 2 over x square. And what is dx? This is this term that equals to x sine x. This is non-homogeneous second order differential equation. Okay, and here, look here, this is a0x, a1x, a2x, and of course dx. These all are continuous function in this domain where x belongs to I. So this is x belongs to this interval. Okay, so here in this problem, you know that this is this y1. There are two solutions of that, say x square. These are the two solutions, and that solution are linearly independent solutions, okay, of the homogeneous equation. So homogeneous equation means we take ly that equals to 0 on this given interval. Okay, so if these two are linearly independent solution of this given differential equation, so we have to find what is the Roskian of that part. This numerical is belongs to that where method of variation parameter. Okay, so where we only give the derivation of that, but we had not solved any problem on depending on that variation of parameter method. Okay, so that's why we take here a problem which belongs to that method. Okay, so if y1 and y2, these are the Roskian of okay, so we have to calculate the determinant of this y1 x, y2 x, and y1 prime x and y2 prime x. Okay, so here what is the y1 is x, and that is x square, and differentiation of that is 1, that is 2x. So this equals to 2x square minus x square. So this is equals to simply x square. Okay, so we have to find the particular integral. So what is the value of u1 x? From that formula, you know that this minus of integral y2x dx over a naught x Gaussian of y1 and y2. Okay, and this dx. So what is the value here? So this equals to what is y2? Y2 is x square, and this is dx. Dx is x sine x over what is a naught? A naught is 1, and Roskian is x square dx. So you can solve this problem. X square are cancelled out. Simply this is integral x sin x. So by using product rule, you can find x cos x minus sin x. Similarly, what about u2x? So u2x is integral y1x dx over a naught x Gaussian of y1 y2 of dx. So this equals to integral. This is what is y1 is x. This is independent solution, and dx term is x sin x over 1 x square dx. This is a simply x square cancel out sin x integral, it is cos x. So you can find easily what is un and what is u2. So the particular solution of his problem is so the particular solution, that is yp, this equals to u1 x y1 plus u2x y2. Okay, so here you can find what is the value of un(x). Un(x) is this thing, this into y1. Y1 is x. So here you multiply it by x here. So x square cos x minus x sin x. And here, if you multiply it by x square.
Minus का integration minus cos x.
Okay. Yes. Okay, this is minus cos x. Okay. So if you multiply by here y2, this is x square here. So this is x square cos x, and here this is x square cos x. So these two terms are cancelled out, and simply you have x sin x term. So this equals to, if you multiply here, so you get yp. Yp is equals to this is minus x sin x. Okay, so this is your particular solution of that problem. Okay, and what is the general solution? So general solution is y is homogeneous solution plus particular solution. What is a homogeneous solution? So homogeneous solution is simple c1 x and c2 x square. These are the two linearly independent solution, and minus of x sin x. So this is your general solution. This is general solution, this is particular solution. So by using a method of variation parameter, you can solve easily what is the solution of this type of equation. Okay, so that part is missing. So that's why we have done this part for.
हेलो सर। सर ये हम कैसे हमको पता चला कि जैसे y1 बराबर x लिए एंड y2 बराबर x स्क्वायर, तो सर कैसे LI सोल्यूशन होगा? एक बार फिर से समझा दीजिए जरा।
ये दोनों तो निर्मल उन्होंने ऑलरेडी जब हम लोग कर रहे थे तो ये वहीं से उठाया हुआ है ये पार्ट। तो ये पार्ट तो हमने वहां पे किया। ये आप यहाँ पे देखें कि x, अगर आप इसकी वैल्यू अगर आप y = x अगर आप पुट करते हो यहाँ y = x here and y prime, so this satisfies this equation. Okay, if we take this equals to 0 homogeneous equation, so y = x इसके एक सोल्यूशन होंगे, y = x स्क्वायर अगर आप पुट करते हो तो भी इसके सोल्यूशंस होंगे। ओके, तो दोनों सोल्यूशन जो है वो हमारे, अब आप ये कहते हो कि क्यों LI क्यों है? तो LI क्यों है? क्योंकि आप गॉसियन निकाल के देख ही रहे हो कि क्या है। ठीक है, तो ये दोनों हमारे सॉल्यूशंस हैं और दोनों के दोनों हमारे गॉसियन आपने यहाँ निकाल लिया है कि ये हमारे जीरो नहीं होने चाहिए उस डोमेन में। डोमेन आपने अपना इन्फिनिटी लिया है। ओके, तो इस तरह तो वहां से आपने निकाल लिया। तो ये पार्ट तो वहां पे किया है। ओके, तो
मैट्रिक्स मेथड से कर सकते हैं।
हाँ, किससे
मैट्रिक्स मेथड जो आपने अभी बताया,
मैट्रिक्स मेथड से भी कर सकते हो, कोई दिक्कत नहीं है, बिल्कुल कर सकते हैं। वो तो आप फ्री है, चाहे इस मेथड से करें चाहे उस मेथड से करें। लेकिन वहाँ पे प्रॉब्लम क्या है कि वहाँ पे उसमें थोड़ी सी है कि वहाँ पे जो हम करते हैं वहाँ पे हमारे अगर कोफिशिएंट अगर कांस्टेंट है देन आप वहाँ पे आइगन वैल्यूज निकाल लेंगे। बट यहाँ पे आइगन वैल्यूज जब आप निकालोगे दिस इज अ फंक्शन ऑफ x। ओके, तो वहाँ पे कांस्टेंट मैट्रिक्स नहीं होगी, दैट इज डिपेंडिंग ऑन दैट x। ओके, सो थोड़ी सी चीजें हैं, तो वहाँ हम एक्सपोनेंशियल मैट्रिक्स की बात करेंगे, अभी फंडामेंटल मैट्रिक्स आएगी, वो सारी चीजें हम भी आगे, वो सारी चीजें आनी है। ओके, हाँ, बट अगर वो कांस्टेंट कोएफिशिएंट्स हैं अगर, ओके, if these are constant coefficient, then no problem, then आप आराम से मैट्रिक्स लिख लोगे, तो उसकी सारी एंट्रीज क्या होंगी, कांस्टेंट होंगी, तो आइगन वैल्यूज आप जो निकालोगे वो एक न्यूमेरिकल होगा। ओके, तो उस केस में प्रॉब्लम नहीं है, लेकिन जब यहाँ पे जब आप जाओगे तो यहाँ पे वेरिएबल्स भी फॉर्म है, तो थोड़ा, तो उसके लिए हम लोग एक्सपोनेंशियल मैट्रिक्स और फंडामेंटल मैट्रिक्स का कांसेप्ट है, उस पे हम जाएंगे थोड़ी, हाँ, अभी धीरे धीरे वहां पे पहुंचेंगे। ठीक है, अभी तो बहुत ही अभी तो हमें एबल्स फॉर्मूले पे भी जाना है। ओके, तो नेक्स्ट टॉपिक है, सो next remark, if we consider an equation, and if you write this equation is a naught x y double prime a1 y prime a2x, say this is y, and this is homogeneous, and say this is equation number, say a, when x belongs to interval r. Okay, and what is the coefficients here? So where this a0, a1, a2, this all are, if you write here d, then d also d are continuous function. So here this is mapping from that interval to r are continuous function. Okay, and of course this term is not equal to 0 due to in that domain, then in that domain that is x belongs to y, because in that sense this x is a your single point. Okay, so if we assume that there are two functions which are twice differentiable function. So if we take u and suppose v ad to twice differentiable function on the given interval. So if these two are twice differentiable function, so what is the value of u l of v minus v l u? Okay, so we have to find this value. So here u, so you can write u, and what is v? So if you're putting here what is lv? Lv is a naught x v double prime plus a1x v prime plus a2x and v. Okay, minus v, what is lu? So here put here lu, that equals to a naught x u double prime a1x u prime a2x u. Okay, and here we try to find the value of this. So here look here, a naught term is common, so we can write a naught x and in bracket u v double prime, and here minus v u double prime. Okay, so this term. Second one, if a1 term common, so if we take a1x is common, so here u v1 v u v prime minus v u prime. Okay, and last term is this is a2 x, if we take common, this is uv minus VU. So this is same term. So this equals to 0. So this term is 0. Okay. So now you can rewrite this is A naught x and U V prime minus V U double prime plus A1x. This is U V prime and VU prime. Say this equation is CP. Okay, and you know that the Roskian, if we are interested to find what is the Roskian, so Roskian of this U and V, this is given by this is W of UV, and this equals to, you know that this first differentiation of second minus second differentiation of first. Okay, so this is the Roskian of this two. This is determinant of UV upon U prime V prime. So this value equals to this thing. Say this is equation number C. Okay, and if we differentiate this Roskian, if we differentiate this Roskian, so this equals to, so this, which gives this, if we differentiate over x of that Roskian UV. Okay, so what is the value here? So this equals to D over dx of, if we differentiate both sides, this equals to U V prime and V U prime. So if we differentiate, so here this is twice differentiable function. So this is using product rule. So this is first function differentiation of second plus this thing, and minus, if we differentiate this to first function, and here this becomes first differentiation of second. So first differentiation of second. Okay, so look here, if it's these two terms are same, so this are cancelled out. Okay, so this equals to U V double prime minus V minus V U. Okay, so this question number A, B, C. This is suppose D. Question number D. Okay. So here you have these values. So from question number B, this equation of B is simply on the left hand side is U L V minus V L U, and this equals to this term. Okay, so this equals to this thing. So here, what is the value of this U V double prime minus V U double prime? So this value is equals to D by dx of Roskian. And what is the value of this U V prime and V U prime? This value is from equation C. This is the Roskian. So if we put this and this value in equation number B, so then from equations B, C, and D, this gives the relation is U L V minus V L U. This equals to, this is to left hand side, this equals to A naught x, and this equals to, this term is D by dx of D by D of Roskian UV plus A1, and this term is Roskian UV. Okay, so here this is your main relation, and this is an important relation, and we call this equation number star. Okay, so here you can find U of LV minus V of LU. This equals to this thing. Okay, so from this equation star, there is theorem, and the theorem, the statement of that theorem you can write in next page. Next page, what is the theorem? And from that theorem, you find the Abel's formula. Okay, so next page, we write the theorem, and this statement of that theorem is if u and v are twice differentiable function on a given interval, then u LV minus V LU, this equals to A naught x d by dx and Roskian of uv plus a1x uv. ओके, तो ये अभी अभी हमने यही चीज प्रूफ की, यही है कि इफ u and v आर ट्वाइस डिफरेंशियल फंक्शन हो तो ये कंडीशन होल्ड करेगी. कैसे करेगी? अभी जस्ट हमने प्रीवियस पेज पे हमने ये चीज करके दिखाई आप. ओके, यहाँ पे L है क्या, तो आप इसे दोबारा लिखने की जरूरत नहीं है. सो Ly इज गिवन बाय इक्वेशन A. ओके, तो अभी लास्ट पेज पे जो इक्वेशन A लिखा था दैट इज योर Ly. तो यदि ऐसा है तो हमारा ये चीज ऐसी होगी. ओके, एंड नेक्स्ट एडिशन टू दिस रिजल्ट, एक चीज और इसमें कर लें. इन पार्टिकुलर if your Lu and Lv if that equals to 0 हो जाए. Okay, if Lu in particular case, if this is 0, then this Roskian satisfies if this is 0, this is 0, then Roskian satisfies a naught x d over dx uv plus a1x Roskian uv. Okay, so this Roskian, this equals to 0. If this term is 0, this term is 0, so overall that left hand side equals to 0. So this Roskian satisfies this relation. Okay, and this is if we divide by this a naught term here, a naught term is here, so this is a linear differential equation, first order linear differential equation. Okay, so try to see that if you can, this is also equals to d over dx of Roskian of uv plus a1x a naught x, this Roskian of uv, that equals to 0. Okay, so this means this is something d over dx of some function plus any function that is p function of x, and that is say that if we suppose this is y, so this is equivalent to look like differential equation look like as dy over dx plus py equals to 0. Okay, py equals to 0. Okay, so this is your problem. So here what is, you can solve this by linear equation, because this q term is 0, or you can solve this by variable separable. This is dy over y, that equals to minus p dx. So if we integrate both sides, that equals to log y, that equals to minus px, and integral of that. Okay, so integral of p of dx. Okay, so what is your y is exponential of integral this and plus arbitrary constant. So here this is a k. Okay, so from variable separable method you can solve this type of differential equation. Okay, so here if we try to find what is the value of this function, that is y, that is Roskian of uv. So here you can note that, and the Roskian of this u and v, that is you can, this means Roskian of uv, okay, uv is given by, this is given by this formula, that is Roskian of uv. By this similar result you can write this k with a constant, exponential of that is minus of p. What is p here? P is this term. This is minus integral a1x over a0x dx. And what is k here? So here k is constant. Okay, so this formula, which is a Roskian of this function, Roskian of this u and v, which is defined by this, and this formula is known as Abel's formula. Okay. This is the Abel's formula, which is the Roskian of u and v is equals to this thing, exponential of that. But one condition is here, when this is for homogeneous condition. If lu equals to this is 0, then this condition holds. Okay. If this equals to any if a non-homogeneous term, suppose dx, then this condition doesn't hold. Okay. So this is for if two solutions which satisfies this second order homogeneous differential equation, then the Roskian of that two can be expressed in this form. Okay, where a naught be the coefficient of the second derivative term and a1 be the coefficient of first derivative term. Okay, so here in okay, so ओके, सो नेक्स्ट क्लास में करेंगे, क्योंकि अब तो समय 10 मिनट्स हैं, और मेरे ख्याल से जो नेक्स्ट प्रॉब्लम है कि व्हाट इज द जनरल सॉल्यूशन ऑफ दैट. ओके, तो हम स्टेटमेंट लिख देते हैं और उसे नेक्स्ट क्लास में कोशिश करेंगे, क्योंकि थोड़ा टाइम लगेगा, थोड़ा लेंदी है वो. तो नेक्स्ट पेज by using this Abel's formula we can find the general solution of any non-homogeneous differential equation. Okay, so okay, तो रहने ही देते हैं, आज यहीं तक रहने देते हैं. ठीक है, हम नेक्स्ट टर्म पे उसे स्टार्ट ही करेंगे. अब हाफ पोर्शन करें. ओके सर, ठीक है, ठीक नहीं है, हाफ पोर्शन आज करें, फिर हाफ एंड. ओके, चलिए आज आज इतना ही करते हैं. ओके, तो नेक्स्ट क्लास में हम आगे उसको एक्सटेंड करेंगे. ओके, चलिए. ओके आज. ओके सर, थैंक यू.
ओके सर, थैंक यू सर.
चलेगा.